final video, we're going to talk about division. So division involves finding the conjugate. The purpose of the conjugate is when you FOIL, you want it to be that difference of two squares look that we did before, 2 minus x times 2 plus x. And what happens with this is when I use the imaginary part, that I in the middle is going to fall apart. If you remember the method to look at a difference of two squares or lookalikes, all I have to do is square the 2, square the x, and there's always a negative in between. And the purpose of that is, notice I don't have any x term. So what I'm trying to do is get rid of the imaginary part that when we FOILed before, there was always that I, or the complex part of the number in here. When I'm doing division, I have to get rid of it. It's someone's weird rule that said, hey, you cannot have an I in your denominator. So when you're talking about the conjugate, it's the opposite of the imaginary part. The constant has nothing to do with it. So as a couple of examples, 5 plus 4i, the conjugate is 5 minus 4i. Negative 2 minus 3i, I don't care about that this is negative, it's just that imaginary part that I'm looking at. So the conjugate is negative 2 plus 3i. If there is no constant in there, it's just an imaginary, it still has a conjugate. And negative 3i's conjugate is positive 3i. And I apologize for squishing this together, but I'm trying to get it all in one little screen. All right, so a couple quick examples. If I'm going to do this division, 3 minus 3i divided by a negative 4i, I can't just cancel out the i's. That's wrong, that's bad. I will pull your fingers off if I were actually in class with you. What you're going to do is multiply the top and the bottom by the conjugate. So I'm going to multiply negative 4i times positive 4i. I'm going to multiply 3 minus 3i by a 4i, which means I'm going to have to distribute. So I'm going to put some parentheses around this to remind myself to do that. In the bottom, I'm going to get a negative 16i squared. Just like in the multiplication video, if I see an I squared, I'm going to change it to a negative 1. So now I have a negative 16 times a negative 1, which is positive 16. Almost always this denominator is going to come out with a positive constant. Every once in a while it's a negative, not very often though. Okay, in the top, I'm going to distribute 3 times 4i, which is 12i. 3 times 4 is 12. I times I is I squared, and I put that minus sign in between. I have to get rid of that I squared as a negative 1, so I have 12i. Remember, I don't care about the I in the numerator, it's only in the denominator I have to get rid of it. Negative 12 times negative 1 is positive 12. Okay, for the sake of this, I'm not going to simplify it. You normally will see versions of this where you factor it out, a greatest common factor, or you see it written as an imaginary fraction with some kind of constant fraction. I don't care if you guys do that. Simplifying purposes is fine. 12 and 16 all divide by 4, so I would end up with 3i plus 3, all divided by 4. I'm not going to separate the imaginary and the constant part. As I said, that's beautiful book answer. If you guys Google this, how you're going to simplify such a problem, you'll see that. So I don't really care if you do it that way, but that would be the beautiful book version of it. All right, so one more really quickly. First, I look at the conjugate. Negative 1 stays negative. It's this part that I'm going to change. So negative 1 times 8i is the conjugate of this denominator only. I don't care if there's an imaginary number in the numerator. You never use the conjugate there. So I'm going to multiply negative 1 minus 8i to the top and the bottom. All right, denominators first. So now I have lookalikes. So negative 1 squared is 1, always a minus. 8 squared is 64, I squared. I'm going to cross that out and put a negative 1 there. So I have negative 1 plus 64. So my denominator is a nice, beautiful 65. In the numerator, I'm not going to divide this up and FOIL it out or distributive property it. I'm just going to kind of walk through it. You would certainly be able to draw a box or use the distributive method. But what this says is 5 times a negative 1, 5 times negative 8i, 6i times a negative 1, and 6i times a negative 8i. So a negative 48, and now I have my I squared. I'm going to cancel that out and put a negative 1. So now I have negative 5 plus 48. And I have negative 40i minus 6i, which is negative 46i. Again, if I could, I would simplify this. 43 is prime, so there's nothing else I'm going to write. I'm not going to separate the constant and the imaginary fraction. If you guys want to, that's great, again, but you don't have to.